Hello and welcome to today's math lesson. So first of all guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low and touch our toes. Then back up high one more time. And this time, can we go tippy toe high? And while we're there, let's have a wave side to side. And then hands on hips. And let's have a wiggle side to side. Stop. And then another wiggle side to side. Stop. Forwards, backwards, forwards, backwards, forwards, backwards, and stop. And now we can go round and round. Round and round. And stop. And then back the other way. Let's go round and round the other way. Give our spines a nice stretch. And stop. And to finish, we will do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So recently in math class, we've been doing a lot of work with fractions. But can anybody remember in the previous lesson, what did we do with fractions? Excellent. Well remembered, guys. We were comparing fractions. So let's write that phrase on the board first. Comparing, C-O-M-P-A-R-I-N-G. Comparing. And then fractions, F-R-A-C-T-I-O-N-S. So all together, guys, comparing fractions. And what comparing means, it means looking at different fractions and deciding which ones are bigger and which ones are smaller. And then we can put them into order. Now there's 2 different orders we can put them in. If we want to put them in the order of going up, bigger, does anybody remember when we go up? Ascending order. Excellent, well done, guys. When we sort them into ascending order, that means going up. Such as. But then, the opposite direction, when we want to sort them going down, descending. Well done, guys. Well remembered. E, S-C-E-N-D-I-N-G. Ascending means go up. If we walk up some stairs, we're ascending the stairs. If we walk down some stairs, we're descending the stairs. And what we're going to do now, as a recap to the previous lesson, I will draw, or I will write some fractions on the board, and then I will invite students to come forward and demonstrate how to sort them into either ascending or descending order. So first of all, we need some fractions. And the first one we will have five over 8. Okay. Then our second fraction, 1 over 2. And then for our third fraction, we can have 3 over 4. Okay? So we've got 3 different fractions here, and each one has a different denominator. So what I'm going to ask my students to do now is I'm going to ask someone to come forward and sort them into ascending order, which means to start with the smallest one and then to go on to the biggest one. And remember, when we're comparing fractions, what we need to do, we need to draw the diagram and colour in the parts. Because when we have the diagram, it's a lot easier to tell which are bigger and which are smaller. So let's close our eyes, guys, and let's see who can go first. And the pen is now with down. So the first thing we need to do is we need to draw the diagrams of our fractions. So our first circle here, please, Dan. Excellent. Now, how many parts do we need for our circle? 8. So let's have 8 parts to this circle. 2, 4, 6, 8. And how many parts do we need colouring in? 5. So let's have 5 parts coloured in. Excellent, Dan. Well done. And now onto our next circle. How many parts for this circle? 2. The denominator is 2. How many parts do we need coloured in? 1. Perfect. And then onto our third and final circle. How many parts for this one? 4. So let's have 4 parts. And how many coloured in? 3. Excellent. Very well done, Dan. So what we're doing this time is we're sorting them into ascending order, which means starting with the smallest and then moving on to the biggest. So looking at the circles, guys, which has got the least amount of colour? What do we think is the smallest fraction?
1 over 2.
Excellent. You can see 1 over 2. So we can write 1 over 2 as our first fraction because that's the smallest. And then what we need to do is decide which is the next biggest. Is it 5 over 8 or 3 over 4? Look at how much blue. Really? What we're looking for is the next biggest. Yes. You can see the next biggest after 1 over 2 is 5 over 8. And then finally, we know now that our third and biggest fraction is here. 3 over 4. Because we can judge the different shades of the circles to tell us which fractions are biggest, even when we're using different denominators every time. So altogether, guys, 1 over 2, 5 over 8, 3 over 4 are fractions in ascending order. Dan, that was brilliant. High five and a big round of applause for Dan, please, guys. Okay, so that was ascending order. Now what we'll do is one more demonstration with another student and another set of fractions to show how we can compare an order into descending order. But first of all, I need to clean the board. So our first fraction, 2 over 4. Six over 8, well guessed on the 8. And then we need one more fraction. Let's have 3 over, no, 10. Okay, so we've got 3 more fractions. We've got 2 over 4, 6 over 8, 3 over 10. And this time what we want is sorting them into descending order. So that means starting with the biggest one and then working our way down to the smallest one. And now I will choose another student. And now the pen is with Pangpon. So Pangpon, come and join me at the front of class, please. And Pangpon will demonstrate how to compare and order this set of fractions. Okay, so the first thing we need to do is we need to do the diagram so we can tell. So the first circle, Pangpon, here please. And how many parts to the first circle? 2. Oh, sorry, 4. So we've got 2 parts, and then 4. And then, how many parts do we need coloured in? 2. 1, 2. Excellent, Pangpon. And then onto our next circle, how many parts? 8. So one more circle with 8 parts, please, Pangpon. 2, 4, 6, 8. Perfect. And how many parts coloured? 6. Okay, so we've got 1, 2, 3, 4, 5, 6. Excellent. And then our third and final circle, how many parts? 10. Okay. 4, 6, 8. And then one more line for 10. Perfect. And how many parts of this circle coloured? 3. Okay. 2, 3. Excellent, Pangpon. So now we're ready to compare and sort them into descending order. So remember, we want the biggest one first. Which circle has the most blue? Which one can you see the most? 6 over 8, correct. So here we can write 6 over 8 as the biggest, because this is the largest fraction with the most colour. But then, working our way down, which is the next biggest after 6 over 8? How about 2 over 4? Have a look at the colours. You can see here, sorry, Pangpon, exactly half of this circle is coloured blue. This one is less than half. So our next biggest one is 2 over 4. Excellent. And now we know the third and final circle is the smallest, which is 3 over 10. You see, guys, how much easier it is to tell when we draw. When we look at the numbers, it's hard to tell. But if we do the diagram, we can tell by the shades and colours in each circle. So one last time, 6 over 8, 2 over 4, 3 over 10 is comparing fractions and sorting them into descending order. And Pangpon, that was excellent. High five. Big round of applause for Pangpon, please, guys. And what we're going to do in today's lesson is we're staying with fractions, but we're going to learn how to do operations with fractions. And in today's lesson, addition operations, where we can add different fractions together to give us a total. So what we've got now is a PowerPoint presentation for our students to observe, listen to, but also practice speaking and answering the questions. So let's turn to look at the TV screen, guys. So let's take a look at our PowerPoint presentation, operations with fractions, lesson 1. Yes, and the word operations in math means calculations. what we have to do is we have to calculate. And in today's lesson, we'll be doing addition calculations. So here we have a circle. How many parts? 8. And how many parts in green? 2. 2 out of 8 parts are shaded. The shaded portion is 2 over 8. That's like a proper fraction that we've learned already. But what happens when we add another fraction to this fraction now? 4 more parts are shaded. This newly shaded portion is 4 over 8. Okay, so we had 2 parts already. We add 4 more parts. So that gives us now the total shaded portion now is 2 over 8 plus 4 over 8 equals 6 over 8. You see, the total amount of shaded parts, 1, 2, 3, 4, 5, 6. Because what we did, we started with 2 parts, then we added another 4 parts. So that now gives us a total of 6 parts, and the denominator, the total number of parts, is 8. So it's like an addition calculation. All we're doing is adding the parts of the fractions together. How many parts here are shaded? 3. How many parts in total? Okay. 3 out of 10 parts are shaded. The shaded portion is 3 over 10. Okay, so that's like any fraction that we've seen before, a proper fraction where the numerator is less than the denominator, 3 over 10. But now let's add some more parts. 1 more part is shaded. This newly shaded part or portion is 1 over 10. So we're adding 3 parts to 1 part, and what's our total? Any ideas? 3 parts and 1 part, 4, exactly. The total shaded portion now is 3 over 10 plus 1 over 10 equals 4 over 10. We can see here in green 1, 2, 3, 4. But there's 10 parts in total. So the final calculation, 4 over 10. But what happens when the number of parts is more than the denominator? Let's take a look. How many parts here are shaded? 8 parts are shaded. How many parts in total? 8 out of 10 parts are shaded. The shaded portion is 8 over 10. Okay, but now let's add some more parts. 6 more parts are shaded. This newly shaded portion is 6 over 10. Okay, so we had 8 parts, but we've added another 6. 1 and 2 here, 3, 4, 5, 6. So now, how do we answer this calculation?
14.
Not 14 over 10. You're correct in one way, Pakbun, because you add the number of parts. But what we can do, when we have a whole, we just say one whole. The total shaded portion now is 8 over 10 plus 6 over 10 equals 1 whole 4 over 10. Remember about mixed numbers? When we have a whole, we can just count it as 1. And then in the next circle, count the number of fractions. So the total number here is 1, 4 over 10. And that's how we can calculate fractions. When the numerator is higher, we can use whole numbers. Here we have a whole number 1 to represent one whole circle, and then a proper fraction. How many parts here? 4. So we've got 1, 4 over 10. And that's how we add calculations together. Any questions, guys? No? Okay, that was excellent. Well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation so that they can begin to learn how to add fractions together. And remember, guys, whenever the numerator is equal to or more than the denominator, we can begin to use whole numbers. When we have a complete circle or a complete bar, that's one whole number. And then we move on to the next circle with the proper fractions. And we've got a board exercise coming up for our students to learn more. But first of all, time for our stretch sequence. So let's stand up and push in our chairs. And we'll begin with some rotations. Left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now we'll do 5 stretches to our right. 1, 2, 3, 4, 5. And then we'll do 5 stretches to our left. 1, 2, 3, 4, 5. Excellent. Now let's have a little shake. Arms and legs, shake it out. Now we'll take our right hand, find our left foot. Then left hand, right foot. Right hand, left foot. Left hand, right foot. Then one more each. Right hand, left foot. Left hand, right foot. And to finish, guys, we will do 5 star jumps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. Okay, so what we're going to do now is we're going to do some operations with fractions. And in today's lesson, remembering we're concentrating on addition. So what I'm going to do is I'm going to draw some fractions on the board that we need to add together. And then I will have a student come forward and demonstrate how to correctly calculate the addition of both fractions. So first of all, guys, we need some fractions. And the first one we can have 2 over 4. And then we want to add 4. Equals. So let's look at our fraction problem together. 2 over 4 plus 1 over 4 equals. And now let's see which student can come forward and correctly answer this fraction problem. And now the pen is with Prau. So Prau, come and join me at the front of class, please. And Prau will demonstrate how to add these two fractions together. Now remember, when working with fractions, it's always a good idea to draw the circles to help us decide. So first of all, we need a circle with 4 parts. Excellent, Prau. And how many parts do we need in colour? 2. Okay, and then on to our next fraction, another circle with 4 parts. And how many times? We need 1 part. Okay, so now our third circle here for our answer. Four parts. But now, what do? We need to answer by adding these two numbers together. So we've got 2 parts plus 1 part. How many parts? 3. And then we can answer, so how many parts to our circle? 4. 3 over 4, yes. Excellent. You see how we can take 2 over 4, and if we add 1 over 4, we get our answer, which is 3 over 4. And that's how we correctly calculate the addition of different fractions. Prau, that was excellent. Very well done. High five and a big round of applause for Prau, please, guys. Okay, let's do some more, but now let's start raising the numbers, make them a little bit harder, but not too hard so that our students can't understand. Okay, so this time we will use (6 over 10) plus 3 over 10. Okay? So now let's see who can answer this problem for us. And now the pen is with Pat. Pat, come and join me at the front of class, please. Okay, so how many parts to our circles, guys? 10. So Pat, can we have a nice big circle with 10 parts? Okay, so 2, 4, 6, 8, and then 1 more for 10. Excellent, Pat, well done. But how many parts do we need to call it in? 6. So we can have 6 parts in blue. 1, 2, 3, 4, 5, 6. Excellent, well done, Pat. And now we need another circle with 10 parts again for 3 over 10. 2, 4, 6, 8, 10. Well done, Pat. And this time, how many parts? 3. 2, 3. Okay, so now for our answer, we need 1 more circle. And how many parts to the circle? 10. 2, 4, 6, 8, 10. So what we do now is we add the fractions together. 6 plus 3 equals 9. So now 9 over 10. Excellent. You see, we're adding the fractions together. So we need 9 parts in blue. Excellent, Pat. So now we can write the answer to our fraction 9 over 10. Brilliant, Pat. So you can see the denominator stays the same every time because we're working with a circle with 10 parts. But what we do, we add 6 parts to 3 parts, so our answer, 9 parts. 9 over 10. Pat, that was excellent. High five and a big round of applause for Pat, please, guys. Let's do some more now. And this time we'll get a little bit harder. Okay, so this time we will use 4 over 6. Three over 6. So this time we're adding 4 over 6 to 3 over 6. So let's see which students can correctly work out this problem. And the pen will go to Pak Bung. So Pak Bung, come and join me at the front, please. So how many parts to our circles, guys? 6. Okay, so let's have a nice circle with 6 parts, Pak Bung. 2, 4, 6. And how many parts in blue? 4. Okay, that's 4 over 6. Our next circle needs how many parts? Needs 6 parts. Okay, so our second circle with 6 parts. 2, 4, 6. And how many parts in blue? 3. Okay, so we have 4 over 6 plus 3 over 6. So now we need to answer. So let's have another circle with 6 parts. Excellent, Pak Bung. 4 over 3 equals 7. How many parts do we have? How many parts? We have 6 parts. So now our answer is more than the parts of the circle. What do we need to do? First of all, let's call it in all 6 parts of our circle. Excellent. So how many parts do we have, guys? 6. How many do we need? We need 7. So that means let's have one more circle into 6 parts. 4, 6. Now, how many parts of this circle? 1. So what's our answer? Now we have a full circle and a fraction. Anybody remember? How do we answer now? 1. We've got a whole 1. 1 and 1 over 6. So write a big 1 here, Pak Bung. Because that's 1 whole, and then the fraction 1 over 6, because this is the fraction. So you can see 4 over 6 plus 3 over 6 means we get a whole number, because 4 plus 3 equals 7, which is more than the denominator. So we have to use another circle to give us our answer, 1 and 1 over 6. Pak Bung, that was excellent. High five and a big round of applause for Pak Bung, please, guys. Now let's do one more together before our students move on to their worksheet activity, just so they're clear about using whole numbers. 2 over 8, okay? Plus plus Okay, so this time we're adding together 3 different fractions. So let's see who can correctly demonstrate how to answer this problem. And now the pen is with Lacau. So Lacau, come and join me at the front, please. So first of all, we need to draw our circles. And how many parts to our circles, guys? 8. So Lacau, the first circle is 2 over 8. So 2 parts need to be coloured in blue. Excellent. Now on to our next circle, 4 over 8. And how many parts in blue? 4. Exactly half. And then our third circle we're adding together, because this time 3 fractions, 3 over 8. Excellent, Lacau. Very well done. So we've got, guys, 2 over 8, 4 over 8, and 3 over 8. So now let's answer. So let's have our circle with 8 parts. 2, 4, 6, 8. Perfect. So now let's add the fractions together, guys. 2 plus 4 equals 6. 6 plus 3 equals 9. But wait a moment. We need another circle. So what we do is we can colour in all the parts here. Because how many parts does the circle have? 8. Or how many parts do we need? 9. So that means we need one more circle cut into 8. And how many parts of this circle are coloured in blue? 1. Well done, Nadia. So now, what's our answer? Remember when we have a whole? 1. One big 1 because it's the whole. And then what's our fraction here? 1 over 8. Excellent, guys. Well done. You see? When we have more for the numerator calculation than the denominator, we get our whole. So our answer is 1 over 8. Lacau, that was brilliant. High five and a big round of applause for Lacau, please, guys. And now it's time for our worksheet part of the lesson. So teachers, make sure your students all get their own worksheet. And what we've got in today's lesson is a worksheet containing 6 addition of fractions calculations, just like the ones we've seen in the PowerPoint presentation and the board activity. What we're asking our students to do is add together the different fractions and then give the final total at the end. And remember, guys, draw your circles and colour your parts, because it'll help you to answer them correctly. But what's the first thing we need to do? Names on top. And give our students around 12 minutes for this activity. That's 2 minutes per question, and help them with anything they need. So Lacau, this one's for you. Bang one for you.
Thank you.
You're welcome. Prel, here's yours.
Thank you, teacher.
You're welcome. Down for you.
Thank you.
You're welcome. Chew for you.
Thank you, teacher.
You're welcome. Nadia, here's yours. You're welcome. Pat, for you. You're welcome. Pak Bung, you're welcome. Annette, for you. So names on top first, guys, and then have a go at adding the fractions together. And remember, if you end up with a fraction that's more than the parts, you need a complete circle and count that as a whole. So if you need any help with any of the answers, let me know. I can help you on the board. And don't be afraid to show your working out on the worksheet, guys. Draw your circles and your calculations. It's good to see your working out because it means you understand. So Pangpon, names on top, and then number 1. 2 over 4 plus 1 over 4. Excellent net. 2 over 4 plus 1 over 4 is 3 over 4. Excellent, Lackout. So we've got 3 over 8 and 6 over 8. So we need a new circle because we have one whole. 1 plus 1 over 8. Perfect. But where's your circles? Let's see. Because if we have 3 plus 6 equals 9, which is bigger than 8, so we need one circle and then one more. We can't have 9 over 8. What we do is we use a whole number because we don't want improper fractions. So instead of 9 over 8, it's 1 and 1 over 8. Anytime you get a full circle, guys, count it as 1 and then start with a new circle. Perfect. Well done. You see 1 and 2 over 10. Instead of 12 over 10, that's improper. We have 1 whole and 2 over 10. Well done, guys. So Nadia, instead of 9 over 8, what we'll do, that's correct, it's 9 over 8, but what we need, if we get a whole, count it as 1, and then 1 over 8. Okay? Because we don't want the numerator more than the denominator. So if we get a full circle, count it as 1 whole, and then have a second circle with the fractions. 3 over 10 plus 5 over 10 plus 7 over 10. Yes. So 3 plus 5 equals 8. And then plus 7. 8 plus 7, 15, yes. So it's 1 whole and then 5 over 10 in the second circle. Anytime we get a full circle, guys, count it as a whole. So 5 over 10, 7 over 10. So what's 5 plus 7? 12. So we've got 1 whole and then 2 over. So 1 and 2 over 10. You see, because we've got 5 and 7 equals 12. But we've got 10 here. So if we use 1, and then 10 minus 12 leaves us with 2. So our answer, 1 whole and 2 over 10. Welcome back to class. We hope your students enjoyed the worksheet activity where they had to add together the different fractions and come up with a final total at the end. And it's a good idea when working with fractions always to work out using diagrams because it helps you to calculate better. And teachers, if you need to demonstrate further, you can always use the board to show the students how to do it correctly. But that's all we've got time for today. So we hope you found it interesting and enjoyed the lesson and now understand operations with fractions involving addition. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Goodbye. Bye-bye. See you again soon.